Yes, try to complete this. Use the pipeline which we assume. You just need to analyze that which instruction is busy at the fourth cycle and fifth cycle. Yeah, please assume that there is a structural hazard. If there is a structural hazard, they must wait. Yes. Yes. Try to do. Let's finish this before leaving. You can add the table simply by just clicking on more tools. There you find the tables. Okay. Click on table. Okay. And you can add the tables like this. So give the table name like cycle. Cycles. And just enter these instructions here. How many? 1, 2, 3, 4. 1, 2, 3. And then just give the first instruction. Control C. Just it here. Control V. Second instruction. Control C. Paste it here. Control V. Third one. Here the register file is accessing, so be focused on register file. And assume there is a single instruction memory only, single memory only. So now you just enter the first instruction will be here in instruction fetching stage. That will be in the first cycle. So in the second cycle, instruction 1 enters into the instruction decode stage. Instruction 2 enters into instruction fetching stage. Because instruction 1 is reading the register file, instruction 2 will be from the memory access. So in the third cycle, instruction 1 enters into, okay, let me just use this as insert in the center. Okay, yeah. Yes, use it. Oh. Oof. So it enters into the execution stage. Instruction 2 enters into the instruction decode stage. Instruction 3 enters into the instruction fetching stage. So at the fourth cycle, instruction 1 enters into the memory access stage. Instruction 2 enters into the execution stage. The execution stage. So instruction 3 enters into instruction decode stage. Correct? So instruction 4, whether this instruction 4 will allow inside the pipeline or not. Instruction 4. Instruction 1 is in the instruction memory. So instruction 4 will not be allowed in the fifth cycle. That will be stall. It's execution. Stall the execution. That is not allowed inside the pipe because at the fourth cycle, both instructions are accessing the memory access unit. So the stall is, okay, let me just, okay. So the stall, the pipeline pass. And in the fifth cycle, instruction 1 into write back stage, instruction 2 into the memory access stage, instruction 3 into the execution stage. At this stage, again, instruction 2 and instruction 4 both try to access the instruction memory, that memory. So again, it will start. It will not allowed inside the pipeline. So at the sixth cycle, instruction 2 enters into the write back stage. Instruction 3 enters into the memory access stage. Okay. And instruction 4 still have to wait. Is that correct? Oh, let me just write it as write back stage, memory access stage. Then in the seventh cycle, instruction 3 enters into write back stage. Okay. Then instruction 4 will be allowed inside the pipeline. So that is in the instruction fetching stage. Decode, execution, memory access, right. So total in how many cycles it will finish then? Oh, sorry. This one is the seventh. Write back stage enters into instruction fetching stage. The eighth cycle, it's into the instruction decode stage. Then in the ninth cycle, in the execution stage, in the 10th cycle, memory access stage, the 11th cycle into the write back stage. So these instructions executed in how many cycles means total 11 cycles. So here the question is, assuming that there is a structural hazard, so then the pipeline execution stops its execution. Okay. So 3 cycles it has to wait. If there is no structural hazard, then this problem will be solved. I hope it's clear, right? Does that make sense? Austin, I see I was off by a bit. Mismatch, yes, I was having some technical difficulty, but very good from my previous. Okay. So in your assignments and exams, it will be effective. Okay. Let me just use this. Yeah. So this kind of questions will be asked. So please be cautious while analyzing these instructions. Here there is no write back issue, but there is an instruction fetching issue is there in between instruction 1 and instruction 2, that is add instruction and multiplication instruction. Uh, yes. Oh. Sense, bold. Is it make sense for everyone, those who are doing the activity? Is it good, helpful? Yes, that's correct, Haley. We need to figure out where there is a stall. If it is asked that assume there is a structural hazard, in that case, we assume that which instructions are having the same issue. The 4th cycle, add instruction is in the memory access stage. Multiplication instruction, if it enters into instruction fetching stage, it is also going to access the same memory. So that's not possible. So that's all from my side. If you like this activity, I will still open for another 10 minutes. If you like this activity, please give your valuable comment in the chat box. Meanwhile, I would like to mute myself. If any doubts are there for anyone, please write your question in the chat box. I will be here to answer. Yeah, Kashmi, when there is instruction dependence, there will be a register file will be accessed for read and write operation. So then there will be a stall in the write back stages. If suppose multiple instruction, the fourth instruction is in the second sequence, suppose, then it has to wait until the execution of the fourth cycle. Alexander, yeah. So if the fourth instruction, or simply if you write this, the subtraction, suppose R1, that means this instruction must wait until this write back stage 5 cycles. Yeah, if there are structural hazard, it must wait. Pipeline. If that problem is solved, that means no issue. Does that make sense? Yeah, yeah. Austin, yeah, interesting to see how it speeds up and how the inevitable currency issue was resolved. Thank you, Professor. Thank you, Austin. Alan, thank you, Carson. Okay. Alexander, yes, I liked the activity. It was good visualization of what's going on. Thank you. Really, this lecture was interesting to see how pipelining actually overlap instructions instead of doing everything one at a time. The part about structural hazard was kind of cool too, because it showed how even with a good design, things can still conflict when instructions try to use the same hardware at the same time. So this class activity helps tie it all together. Hope everything has a great day. Thank you, Professor. Thank you, Haley. Ask me if depend on previous, at which stage does it determines to wait? Is it at the install stage of, yes, correct. That's in the instruction fetching stage. Correct, Kaspi. So here Lucas tried. Good. And Austin Ranche, total 11 cycles. That's wonderful. Good. And Jonas, you're crazy, man. I appreciate your work. Super. That's really appreciable. Cost me, yeah. Thank you, Kasmi. So, yeah, thank you all.